My name is Macy and I'm here today to present on behalf of my workshop team our conclusions and recommendations to Build Smart New York. First off, I'd like to thank Steve Cohen for his insight and guidance throughout the semester, managers Ben, Sally, and Bridget Hardy, my workshop team, and you all for your time and attention. So today I'm going to walk you through what is the problem and what is New York State doing about it, and then where did our workshop team come into it? What challenges did we have along the way? And then what did we find and recommend to Build Smart New York? So first off, the problem is a lack of energy efficiency. According to the Environmental Protection Agency, the average building wastes 30% of its energy. And when people think about improving energy efficiency, they often think of large retrofits, capital investments, such as high-performance buildings and efficient appliances. However, it's been found that even the most efficient appliances deteriorate, buildings get out of sync, and the user behavior of any type of appliance contributes significantly to losses in energy efficiency. This category that refers to the control, upkeep, and use of property and equipment is considered operations and maintenance, and changes in this can improve energy efficiency, improve reliability and safety, as well as provide economic savings. So how is New York State dealing with the challenge of energy efficiency? In December 2012, Governor Cuomo signed Executive Order 88, which mandated a 20% reduction in government buildings 20,000 square feet or larger by 2020. This affects more than 2,000 buildings in New York State, which only makes up 14% of the building stock. But this 14% makes up 90% of the state's energy consumption and cost. Build Smart New York is a government agency that was tasked to oversee and implement these energy efficiency improvements. So Build Smart New York is housed within the New York Power Authority and has four main tasks: to benchmark energy usage, construct energy master plans, target retrofits, and identify operations and maintenance best practices. And that's where our workshop team comes in. We took a three-pronged approach. We conducted a literature review looking at government publications and academic research. We analyzed over 15 international and domestic case studies, and we talked to more than 25 operations and maintenance experts, including energy efficiency managers and engineers, facility managers, and policy advisors. We also divided it into facility type because that's how Build Smart New York reports the data. Now, many of the services that may come to mind as government services are local services. So the state doesn't provide a lot, but what they do provide is universities, which consist of residential, academic, and hospital facilities that make up 51% of the state's energy usage, followed by correctional facilities accounting for 17%, health care and services accounting for 12%, and office buildings for state agencies and transit making up 9%. It's important to note that the 9% for the transit is the buildings and supporting infrastructure, not the transit itself. So what challenges did we face? Operations and maintenance often consists of very basic and unexciting tasks that each contribute very marginally to savings, so they're often not included in case studies. For very similar reasons, it's very difficult to quantify changes in operations and maintenance, making it hard to attribute savings to each individual measure that's undertaken. We also had to be very cognizant of differences in political climate, available funding, building types, and climates that may make some case studies very difficult to apply here in New York. So to give you an example of what we found, I'm going to walk you through one of our case studies. This is Cornell University, a very large university located in New York State, meaning that it faces many of the same opportunities and challenges such as the climate that other large state universities will. It also is a combination of public and private funding. So Cornell is an award winner for energy efficiency, and operations and maintenance has contributed significantly to their improvements. They took a four-step approach. The first was to track the data. They installed sensors in 50 buildings around campus and created online dashboards to monitor the trends and the peak energy usage to help develop a baseline to compare their future usage to. This image here shows the online dashboard display for Furno Hall, an academic building on your right, that shows how the energy use increases throughout the general academic day. Now, this online dashboard also provides information such as kilowatt hours, pounds of carbon dioxide, and daily energy costs to help provide context to anyone that may view the site that potentially doesn't know what their energy usage means. Next, they use this information to identify areas for improvement, and third, address the maintenance issues. They created a conservation-focused preventative maintenance team that's comprised of 8 technicians and 1 foreman. Now, this team costs $1.5 million a year, but actually saves them over $3 million in energy costs. Their job is to evaluate the data and calibrate building automation. This map here on your left is a map of Cornell and shows the buildings with automatic control in red. That's 89% of the campus, so it's extremely important. They've also worked to verify the correct usage of water and air systems. For example, laboratory fume hoods can use up to 3.5 times the energy of a typical house per year. But at Cornell, they found that by using a hibernation setting on weekends and breaks, they can reduce the annual energy cost by 40%. So this graph on the right shows the impact of using automation and hibernation settings to reduce energy cost. As you can see, it dips down on the weekends and reaches a minimum over Christmas break. The last area of Cornell's improvement has been to educate and engage the community. The Energy Corps is a group of students that promotes sustainability and energy efficiency by identifying potential areas of improvement and reaching out to other students. Cornell has also worked to incorporate it into their curriculum by including such things as a major in energy efficiency and sustainable development. They've also worked to incentivize behavior changes, a combination of changes in building settings, such as turning the thermostat down just 4 degrees, and encouraging users to unplug non-essential equipment, turn off lights, computers, and copiers, and close exterior doors and windows, saved Cornell $140,000 over just 9 days over a Christmas break. They then took some of those savings and allocated them back to the department to reward them for their behavior. We compiled over 15 case studies like this from a variety of places, such as the Massachusetts Department of Correction, a Thai prison complex, and Gunderson Lutheran Hospital. We then used that to analyze how to achieve improvements of operations and maintenance across all facility types, and we divided it up into a 4-step process. First is to plan, to analyze historical utility data, set goals, and create a schedule. Next, staff these initiatives, figure out who in the organization cares about this, and provide training and education to those who potentially don't. Next, promote the initiatives. Encourage people to connect to what their energy usage means by marketing changes and improvements both internally and externally, and providing real-time data. Now, improvements in operations and maintenance energy efficiency is not a one-time fix. In order to ensure continued achievement of energy efficiency goals, it's important that monitoring and modifying continue into the future. So in conclusion, a lack of energy efficiency is costing New York State money, and operations and maintenance has the potential to significantly improve energy efficiency. Successful and efficient operations and maintenance depends on having the equipment, knowledge, and understanding of the baseline energy use. It's important that facility managers and employees receive the proper training and education to properly maintain and use the equipment. It's important to track and monitor energy usage on a real-time basis using systems and technology that helps maximize, quantify, and maintain improvements. Cultural and behavioral changes are critical and can be achieved through motivation and incentive techniques. And because operations and maintenance is a medley of details, and there's a wide variety of people that are involved in the daily operations of a building, it's important that it becomes a consistent program within the work culture that's complete with monitoring and adjustments. I'd like to thank you for your attention, and I'm happy to take any questions.
Why a Thai prison complex?
Why not?
Well, prisons are very challenging because they're on all the time, and because of the safety concerns, often energy efficiency goes by the wayside. So we were really looking for fresh ideas and felt that overseas potentially had new things that we hadn't seen before. So that's why we really divided it up into international and domestic.
Thank you very much.